Working alone, printers X, Y, and Z can do a certain printing job consisting of a large number of pages in 12, 15, and 18 hours respectively. All right. So who's the fastest, by the way? Who's the fastest? X, Y, and Z can do a certain printing job in 12, 15, and 18 hours. X is the fastest. He takes the fewest hours. Right? X is able to finish the job in 12 hours. Z is the slowest. Z alone takes 18 hours. Okay. What is the ratio of the time it takes printer X to do the job working alone at its rate? Ratio of what? Time it takes for the printer X to do the job working alone, which is 12 hours, to the time it takes printers Y and Z to do the job working together at their individual rates. Okay, so what do we need to figure out here? We need to figure out a ratio. What ratio? Time taken by X alone to finish the job is to time taken by Y and Z working together to finish the same job. We have to figure out this ratio. All right, how do we go about it? So one way is we can apply the work formula directly to figure out how long it would take Y and Z to finish the task working together. Basically, 1 upon the time taken by Y working alone plus 1 upon the time taken by Z working alone equals 1 upon the time taken by both two machines working together. Right? I solve this. 1 by t equals whatever LCM, and then 15 plus 18. Overall, t equals, I would need to take a reciprocal, 5 times 18 over 11. I cancelled 1, 3. Right? 5 times 18 or 90 over 11. It's t. What's t? Basically the time. And everything is in hours. So this is 90 over 11 hours. That's how long this should be X and Y. This should be Y and Z. My bad there. That's how long the two would take working together. What do we need to figure out? The ratio of 12 hours is to this ratio, 90 by 11 hours. Right, now it's a matter of just cancelling the common factors, cross multiplying and everything. Right, I'm able to cancel a 6, so I get 2 is to 15 by 11. I take the 11 on the other side. I get 22 is to 15. So the answer here is option D, not C, by the way, which is the second most common answer. Of course, the mistake that you would have made would have been you did not take a reciprocal, or you took an incorrect reciprocal somewhere. But then it's a bigger mistake than that. And I'll discuss that. The answer is D, right? What did I do here? Figured out the time the two machines would have taken together using this formula, the standard work formula. And then I just figured out the ratio. All right. How else could we answer this question? How else could we answer this question? Now, this is one approach I discuss with my students also. I call it the sum common multiple. Sum common multiple. Instead of LCM specifically, the idea is that we can just take any common multiple, whichever one we find easy. Common multiple of what? Of the hours. So 12, 15, and 18 basically, mainly these two figures, because those are the machines that would go on to work together. Right? So let me think of some common multiple of these numbers. The multiple that came to my mind was 180. Right? 15 times 2, 30. Then I was thinking of multiples of 30. And then I was thinking of easy multiples of 18. I was able to come up with 180. Now, why deal with this? So now I'm going to say, let's assume that the total work is 180 units. 180 units. Here, let me give you a quick background about the concept of work. Basically, printers X, Y, and Z can do a certain printing job. Now, whatever that printing job may be, it could be printing 180 pages, it could be printing 1800 pages, one page, whatever, right? Whatever that job is, it takes the machines 12, 15, and 18 hours respectively. So I can assume that work to be some units that actually help me with calculations, right? So I would want a figure that's a multiple of these so that when I need to divide by the hours, I don't deal with any fractions. I can directly just get integer values and my life will be easy. We'll see that in action. So let's say the total work is 180 units. What does units mean? Some units, I don't know. It could be number of pages, it could be number of binders, whatever it is. I don't really care. As long as it's the same for everyone, it's fair. There's nothing wrong here. Now, let's say the total work is 180 units. The second machine, Y, does 180 over 15, 12 units per hour, right? The total work is 180. Y alone takes 15 hours. So per hour, Y takes 12. Y does 12 units per hour. Similarly, Z does 180 over 18, 10 units per hour. Now, together, how many units per hour would these two guys do? Would these two machines do? One machine does 12 units per hour. The other does 10 units per hour. Together, how many units would they do per hour? How do we figure this out? 22, yes. Basically, all we need to do is add them up. Why is that? Again, it's important that we understand work from a very real world perspective. Let's just take a detour quickly to understand. Let's say two people are painting walls. So what would be happening? One guy is painting his walls, and parallelly in the same time, the other guy is painting his walls. And together, how many walls would they have painted in 1 hour? Well, as many walls as the first guy painted, plus as many walls as the second guy painted. Right? So when it comes to work, we can directly add up rates. Why? Because that's how work works. Right here also, one printer is printing and parallelly the other printer is printing. Let's say one printer is able to print 12 units in an hour. The other is able to do 10 units. Together, they would have done 22 units in an hour. Right? This is not a mathematical concept. We can just understand this. That's how work works. Together, they would have done 22 units per hour. So in order to finish off 180 units, how long would they have taken? For 180 units, Y and Z together would take 180 divided by 22 hours. That's the time. Now what we need to figure out is the ratio. So ratio of X's time remains 12 hours only. I don't need to actually worry about X and do anything with X. Right? Because end of the day, what I need to figure out is the ratio of the times. So I already have X's time of 12 hours. That remains as it is. And now for the other two machines, their combined time is 18 by 22. Again, it's a matter of canceling out the factors and everything. Eventually, we get the same ratio again. 22 is to 15. That's the second approach. I'll discuss one more approach here. And then in case you guys still have any questions, we'll discuss. All right. Now, before we get into any calculations, before we get into any equations, any formulae, anything like that, and one reason is because realize a very big percentage of you guys marked C as the answer. And why that would have happened, I'm guessing, but I think why that would have happened is because you either misinterpreted the formula or you made some calculation error in terms of reciprocals and everything somewhere. So before we even get into all those things, let's understand a little bit more about work. First, what I need to figure out is how much time Y and Z together would take to finish the job. How much time would Y and Z together take? What I'm given is that Y and Z take 15 hours and 18 hours respectively. Just to get some idea of roughly how much time they'll take. Let me start off with saying that let's say both these guys take 12 hours each. Right? Let's say Y and Z each takes 12 hours to finish the task working alone. Let's say alone. Now, if these two people who take 18 hours each, or these two machines, sorry, these two printers which take 18 hours each got together, in how much time would they be able to finish the job working together? Each machine takes 18 hours. How much time would they take to finish off the job working together? They would take 9 hours. Half the time. Why half the time? Because in half the time, the first machine would have done half the job, and parallelly, in the same time, the other machine would have done the other half. So combined, they would have finished the work. If the two machines would have taken 18 hours each, working alone to finish the job, together they would have taken 9 hours. Now, why am I dealing with this? I'm dealing with this to get some idea of what the time taken would be for these two machines working together. Okay, what do I do now? Actually, in our question, Y is taking 15 hours, not 18. Right? One machine is taking 15 hours instead of 18. So if one machine is taking 15 hours instead of 18, would these two machines, one machine taking 15 hours, one machine taking 18 hours, would these two machines take more, less, or equal to 9 hours? Can we comment? Two machines work that would have taken 18 hours each would have taken 9 hours. Now what have I done? I've replaced one machine with a faster machine. Right? A 15-hour machine would mean it's a faster machine. So by replacing with a faster machine, now they would take less time. Right? So Y and Z together would take less than 9 hours. This much I can realize just by figuring this much out. In fact, let me not stop there. Let me take it further. What if each of them took 15 hours, let's say? Then how long would they take to finish off the work, working together? 7.5 hours, right? Yep. Given that in our situation, one machine actually takes 18 hours and not 15. What can we say? Would that total time be more, less, or equal to 7.5 hours? It would be more than 7.5 hours. Indeed. So what's the ratio that we're looking for? We're looking for a ratio which is 12 is to something between 7.5 and 9. 12 is to something between 7.5 and 9. Let me scan the options. 4 by 11, gone. 1 by 2, gone. 15 by 22, gone. Now, let me compare the remaining two options. 11 by 4, 12 by 4 would have been 3. 11 by 4 is 2 point something, more than 2, right? Would this ratio be more than 2? No. 12 is to 6 would have been 2. This is 12 is to something bigger than 6. So definitely this ratio is less than 2. That also helps me eliminate the last option. And I get my answer.